First, let me describe what my new book, How Not to Diet, is not about. If you want to be regaled with success stories and testimonials and before and after pictures, you have come to the wrong place. You don't need anecdotes when you have evidence. I wrote this book for those who want the facts, not filler, fantasy, or fluff. I'm not interested in offering dueling anecdotes, and the last thing we need is more dietary dogma. What I was interested in is the science. When it comes to making life-and-death decisions as important as what to feed yourself and your family, as far as I'm concerned, there's only one question. What does the best available balance of evidence say right now? My goal was to create the oxymoron, an evidence-based diet book. The problem is that even just sticking to the peer-reviewed medical literature is not enough. As concluded a commentary in the New England Journal of Medicine, false and scientifically unsupported beliefs about obesity are pervasive even in scientific journals. The only way to get at the truth, then, is to dive deep into the primary literature and read all the original studies. Right? Who's got time for that, though? There are more than 500,000 scientific papers on the subject, with 100 new ones published every day. Even researchers in the field might not be able to keep track of what's going on beyond their narrow domain. But that's what we do here at nutritionfacts.org. We comb through tens of thousands of studies a year, so you don't have to. Whether you're morbidly obese, just overweight like the average American, or at your ideal weight and just want to keep it that way, my goal was to give you every possible tweak and technique we could find to build the optimal weight control solution from the ground up. To that end, we identified 17 key ingredients to the ideal weight loss diet, with a chapter on each. Ideally, foods, meals, and entire dietary patterns should be anti-inflammatory, clean from industrial pollutants, high in fiber and water, low in high glycemic and addictive foods, added fat and sugar, calorie density, meat, refined grains, and salt, low insulin index, friendly to our friendly flora, rich in fruits, vegetables, legumes, and particularly satiating. No wonder a whole food plant-based diet is the single most successful weight loss intervention without calorie restriction and exercise ever published in the peer-reviewed scientific literature and proven in a randomized controlled trial. Start packing your diet with real food that grows out of the ground, and the pounds should come off naturally, taking you down towards your ideal weight. OK, so that's what I spent the first half of the book doing, laying out the optimal weight loss diet. Then I spend the second half on all the tools I unearthed to drive further weight loss for any stubborn pounds that remain. In the first half, we learned that a calorie is not necessarily a calorie. 100 calories of chickpeas has a different impact than 100 calories of chicken or chiclets, based on their different effects on factors such as absorption, appetite, or our microbiome. In the second half, I go a step further and show how even the exact same foods eaten differently can have different effects. It's not only what we eat, but how and when. There are specific foods shown in interventional trials to cause you to burn more fat, suppress your appetite, rev up your metabolism, block the absorption of calories, and effectively take away even more calories than they provide. What's more, the context in which we eat matters too. The same number of calories eaten at a different time of day, in a different meal distribution, or after different amounts of sleep can translate into different amounts of body fat. Distinct forms of the exact same foods can be distinctly fattening. And did you know that combining certain foods together can have a different effect than eating them apart? There's even a food that can prevent the metabolic slowing that your body uses to frustrate your weight loss attempts. Skeptical? You should be. I was too. I went into this thinking I would just, end up railing against all the gimmicky snake oil nonsense out there and put out, the same kind of standard advice on trimming calories and, hitting the gym. I imagine what would set this work apart would be its comprehensiveness and strict grounding in the science. I figured the book would distinguish itself, but more as a book of reference than revolution. I certainly never thought I'd stumble across some novel weight loss strategy. I went into this project with the goal of just creating a distillation of all the best science, but to my delight, I discovered all sorts of exciting new tools and tricks along the way, a treasure trove of buried data, like simple spices, proven in randomized, double-blind, placebo-controlled studies to accelerate weight loss for pennies a day. With so little profit potential, it's no wonder these studies never saw the light of day. And I was even able to traverse beyond the existing evidence base to propose a new method to eliminate body fat. It can't be monetized either, but the only profiting I care about is your health. That's why I donate 100% of the proceeds I get from my books, including this one, to charity. I don't get a single penny from my books, but I get something better: the satisfaction of serving and helping, learning and sharing. Contact your local library or order it for yourself or for anyone you love. Breakfast is widely touted as not only the most important meal of the day in general, but specifically in relation to weight loss. This is not just a pop culture prescription from checkout aisle magazines, but an idea put forward by prestigious institutions such as Johns Hopkins, NYU, Mayo Clinic. Right? Even the United States Surgeon General. Want to trim your waist? Read a headline, American Dietetic Association, try eating breakfast, referring to breakfast as perhaps the best-kept weight-trimming secret. But is it true? The Duke School of Medicine's health newsletter was skeptical. It's always been billed as the most important meal of the day, until now. While it's widely presumed that eating breakfast protects against obesity, the belief is held up as a poster child of biased distortion of the scientific record. No one can argue that there isn't an association between body weight and breakfast. Studies have shown that obesity and breakfast skipping tend to go together beyond a shadow of a doubt. In fact, gratuitously so. By 1998, we already had what might be considered strong evidence of an association between breakfast skipping and obesity, but researchers continued to repeat such studies to the point of ridiculousness. This meta-analysis found that by 2011, the combined p-value had reached 10 to the negative 42. OK, what does that mean? Why is that ridiculous? In science, p-value refers to the chance of getting a result that extreme if, in fact, there really was no such effect. How small a chance is 10 to the negative 42? This is how small that number is. In other words, the probability that the association between obesity and breakfast skipping was just a fluke is less than the chances of winning the lottery not once, but 5 times in a row, and then subsequently getting struck and killed by lightning. OK, so the association between breakfast skipping and obesity is indeed beyond question. We know the association is true. People who skip breakfast are more likely to be overweight. That's beyond a shadow of a doubt. The question, though, is whether that ironclad relationship between breakfast skipping and obesity is actually cause and effect. To illustrate the difference between correlation and causation, let me share an example of the manipulation of science by the candy industry. The National Confectioners Association had the gall to warn parents that restricting candy may make their children fat. They justify this outlandish claim with this study that they funded, of course, that showed that candy-consuming children and adolescents were significantly less likely to be overweight and obese. The industry-funded researchers go on to imply that this exonerates candy, but what's more likely? That cutting down on candy led to obesity, or rather that obesity led to the cutting down on candy, right? In other words, the lower candy consumption may reflect the consequences of obesity, not the cause, right? As parents of obese children try to restrict treats. Similarly, the finding that those who skip breakfast tend to be heavier is equivalent to saying that those who are heavier tend to skip breakfast, right? It doesn't seem to be more likely that overweight individuals might just be skipping breakfast in an effort to eat less, rather than eating fewer meals somehow leading to weight gain? Now it's possible that skipping breakfast could slow your metabolism or cause you to overeat so much later in the day that you gain weight, but you can't know for sure until you put it to the test. Sometimes randomized controlled trials are infeasible, impossible, or unethical. To test to see if parachutes save lives, you can't exactly boot half the people off a plane without them, but you could easily randomize people to eat breakfast or not, and just see what happens. And it turns out eating breakfast does not seem to affect your metabolism rate or sufficiently suppress your appetite. Most studies, 95%, found that eating breakfast tends to lead to the same or greater caloric intake over the day. Even when people ate more at lunch after skipping breakfast, they didn't tend to eat an entire breakfast worth of calories more, and so ended up eating fewer calories overall. For example, feed people about a 500-calorie breakfast, and at lunch they may eat about 150 calories less than those randomized to skip breakfast, but they would still end up with about a 350-calorie surplus over the breakfast skippers. Does this then translate into weight gain over time? Researchers at Brigham Young University randomized 49 women who habitually skip breakfast to either start eating breakfast or continue skipping. If breakfast somehow magically leads to weight loss, then the newly eating breakfast group should benefit. But no, compared to those who continued to skip breakfast, adding the extra meal led to hundreds more daily calories consumed and nearly a half a pound of weight gain a week. If you already eat breakfast and start skipping it, will you lose weight? We'll find out next. Where did this whole breakfast is the most important meal of the day concept come from? The father of public relations, Edward Bernays, infamous for his Torches of Freedom campaign to get women to start smoking back in the 1920s, was paid by a bacon company to popularize the emblematic bacon and eggs breakfast. The role of public relations, he wrote in his book entitled Propaganda, is the, quote, conscious and intelligent manipulation of the organized habits and opinions of the masses, unquote. Public relations specialists thereby constitute an invisible government, the true ruling power of our country. Breakfast is big business. Powerful corporate interests, such as the breakfast cereal lobby, are blamed for perpetuating myths about the importance of breakfast. This editorial in the American Journal of Clinical Nutrition urged nutrition scientists to speak truth to power and challenge conventional wisdom when necessary, even when it looks like we're taking away motherhood and apple pie. Actually, the editorial concludes reducing the portion size of apple pie might not be a bad idea either. So should we break the feast and skip breakfast to lose weight? Though advice to eliminate breakfast will surely pit nutrition scientists against the very strong and powerful food industry, skipping breakfast has been described as a straightforward and feasible strategy to reduce daily calorie intake. Unfortunately, it doesn't seem to work. Most randomized controlled studies of breakfast skipping found no weight loss benefit to omitting breakfast. How is it possible if skipping breakfast means skipping calories? The Bath Breakfast Project, a famous series of experiments run not out of the tub, but the University of Bath in the UK, discovered a key to the mystery. Men and women randomized to either eat breakfast, defined as taking in at least 700 calories before 11 a.m., or fast until noon every day. As in similar trials, the breakfast eating group ate a little less throughout the rest of the day, but still ended up with hundreds of excess daily calories over the breakfast skippers. Those who ate breakfast consumed more than 500 calories a day more. Over 6 weeks, that would add up to over 20,000 extra calories, yet after 6 weeks, both groups ended up with the exact same change in body fat. Wait, how could tens of thousands of calories just effectively disappear? If more calories were going in with no change in weight, then there must have been more calories going out. And indeed, the breakfast group was found to spontaneously engage in more kind of light-intensity physical activity in the mornings than the breakfast-skipping group. Light-intensity activities include things like casual walking, light house-cleaning activities, not structured exercise per se, but apparently enough extra activity to use up the bulk of those excess breakfast calories. There's a popular misconception that our body goes into energy conservation mode when we skip breakfast by slowing our metabolic rate. That does not appear to be true, but maybe our body does intuitively slow us down in other ways. When we skip breakfast, our body just doesn't seem to want to move around as much. The extra activity didn't completely make up for the added calories, though. We seem to still be missing about 100 daily calories, suggesting there may be another factor to account for the mystery of the MIA morning calories. Recent breakthroughs in the field of chronobiology, the study of our body's natural rhythms, have unsubtled an even more sacred cow of nutrition dogma, the concept that a calorie is a calorie. It's not just what we eat, but when we eat. Same number of calories, different weight loss depending on meal timing. Just to give you a taste, the exact same number of calories at breakfast are significantly less fattening than the same number of calories eaten at supper. What? I mean, that's just mind-blowing, right? A diet with a bigger breakfast causes more weight loss than the same diet with a bigger dinner. Because of our circadian rhythms, morning calories don't appear to count as much as evening calories. So maybe breakfast should indeed be the most important meal of the day, after all. When it comes to the amount of steroid hormones we're exposed to in the food supply, milk products and dairy products supply about 60 to 80% of ingested female sex steroids. I've talked about the effects of these estrogens and progesterone in men and prepubescent children, how milk intake can spike estrogen levels within hours of consumption. But in terms of effects on women, I talked about the increased endometrial cancer risk in postmenopausal women, but what about reproductive age women? Might dairy hormones affect reproduction? We've known dairy food intake has sometimes been associated with infertility. However, little is known with regard to associations with reproductive hormones or anovulation, meaning how might dairy do it, by affecting how the uterus prepares or affecting the ovary itself. The researchers found that women who ate yogurt or cream had about twice the risk of sporadic anovulation, meaning failure of ovulation. So some months there was just no egg to fertilize at all. Now we know most yogurt these days is packed with sugar. Even plain Greek yogurt can have more sugar than a double chocolate glazed cake Dunkin' Donut, but they controlled for that. And the results remained after adjusting for the sugar content, which suggests that the risk of anovulation was independent of the sugar content included in many yogurts. Now, we don't know if this is just a fluke or exactly what the mechanism might be, but if women skip ovulation here or there throughout their life, might they end up with a larger ovarian reserve of eggs? Women are starting to have their first baby later and later. There's been a rise in women having babies in their late 30s and 40s. We used to think that a woman's ovarian reserve of eggs stayed relatively stable until rapid decline at about age 37. But now we know it appears to be more of a gradual loss of eggs over time. Here's what the graph looks like, where there's a steady loss starting at peak fertility at one's 20s. This is measuring antral follicle count, which is an ultrasound test where you can just count the number of, next batter up eggs in the ovaries. It's probably the best reflection of true reproductive age. It's a measure of ovarian reserve, how many eggs a woman has left. Okay, so what does this have to do with diet? Researchers at Harvard looked at the associations between various protein intakes with ovarian antral follicle counts among women having trouble getting pregnant. Even though diminished ovarian reserve is one of the major causes of female infertility, the process leading to reproductive deterioration with age is still poorly understood. In light of women delaying pregnancy until older age, the identification of reversible factors that may affect the individual decline might be of significant clinical value. So they did ultrasounds on all the women and studied their diets, and concluded that higher dairy protein intake was associated with lower antral follicle count. In other words, accelerated ovarian aging. Here's what the graph looked like in non-smokers. Significantly lower ovarian reserve at the highest dairy intake, which would be like 3 ounces of cheese a day, compared to the lowest dairy intake. OK, but what do these numbers mean in terms of biological age? Is 16.9 down to 12.7 really that much of a difference? If you look at women with really robust ovaries, a follicle count of 16.9 would be like what you might see in a 36 or 37-year-old, whereas 12.7, what you see in women eating the most dairy, is like what you would see in a really fertile 50-year-old. So we're talking years' worth of ovarian aging between the highest and lowest dairy consumers. Well, it wasn't possible for the researchers to identify the underlying mechanism linking higher dairy protein intake with lower follicle count. They had several educated guesses. One, it could be the steroid hormones and growth factors. Two, the contamination of milk products with pesticides and endocrine-disrupting chemicals that may negatively affect the development of these ovarian follicles and egg competence. Regarding the hormones, studies suggest that commercial milk, derived from both pregnant and non-pregnant animals, contains large amounts of estrogens, progesterone, and other placental hormones that are eventually released into the human food chain, with dairy intake accounting for 60 to 80% of the estrogens consumed, as I mentioned before. Dairy estrogens survive processing, appear both in raw and commercial milk products, are found in substantially higher concentrations with increasing amounts of milk fat, with no apparent difference between organic and conventional dairy products. It's important to realize. It's not just cows that have been injected with growth hormones. These hormones are just in their bodies naturally, and once inside the human body, these bovine hormones get converted to estrone and estradiol, the main active human estrogens, and following absorption, bovine steroids may then affect reproductive outcomes. It's imperative that further studies are designed to clarify the biology underlying the observed associations. This might be crucial, given that consumption of another species' milk by humans is an evolutionarily novel dietary behavior that has the potential to alter reproductive parameters and may have long-term adverse health effects. The 2017 Nobel Prize in Medicine was awarded for elucidating the molecular mechanisms of our internal circadian clock. For billions of years, life on Earth evolved on a 24-hour cycle of light and dark, and so it's no surprise our bodies are finely tuned to that pattern. But put people in total darkness without any external time cues, and our body still continues to cycle in about a 24-hour circadian rhythm. In fact, you can even take tissue biopsies from people and show the cells continue to cycle outside the body in a petri dish. Nearly every tissue and organ in our body has its own internal clock. An intricate system of intrinsic clocks drive not only some of our behavioral patterns, such as eating, fasting, sleeping, and wakefulness, but our internal physiology, our body temperature, blood pressure, hormone production, digestion, and immune activity. Most of the genes in our body exhibit daily fluctuations in expression, making the circadian rhythm the largest known regulatory system in the body. This cycle is thought to allow for a level of predictability and functional division of labor so that each of our body processes can run at the best time. At night while we're sleeping, a whole array of internal housekeeping activities can be switched on, for example, and as dawn approaches, our body can shift back into activity mode. Anyone who's ever had jet lag knows what throwing our cycle even just a few hours off can do, but now we know our circadian rhythms can literally be the difference between life and death. A study of more than 14,000 self-poisonings found that those who tried committing suicide in the morning were more than twice as likely to die than those who ingested the same dose in the evening. In the same vein, properly timed chemotherapy can not only end up being 5 times less toxic, but also twice as effective against cancer. The same drugs, the same dose, but different effects depending on the time that they were given. Our body absorbs, distributes, metabolizes, and eliminates what we ingest differently depending on when it is during the 24-hour cycle. We're just beginning to figure out the optimal timing for different medications, randomize people suffering from hypertension into taking their blood pressure pills at bedtime instead of in the morning. And not only does the bedtime group achieve better blood pressure control and suffer fewer heart attacks and strokes, but cuts their risk of death in half. Yet most physicians and pharmacists tell patients to take them in the morning, potentially doubling their risk of death. If chronotherapy, the optimal timing of drugs, can have such an impact, maybe it should come as no surprise that chronoprevention, the scheduling of lifestyle interventions like meal times, can also make a difference. In the official Academy of Nutrition and Dietetics position paper on effective treatments for obesity, importance is placed not only on the quantity, but timing of calorie intake, suggesting that consuming more calories earlier in the day rather than later in the day can assist with weight management. Some have gone further and even characterized obesity as a chronobiological disease. What evidence do we have to back up these kinds of claims? Well, the timing of calorie intake may have shifted slightly over the last few decades towards a greater proportion of foods later in the day, which raised the question about a possible role in the rise of obesity. Middle-aged men and women who eat a greater share of daily calories in the morning do seem to gain less weight over time, and a study entitled "Timing of Food Intake Predicts Weight Loss Effectiveness" found that dieters eating their main meal earlier in the day seem to steadily lose more weight than those eating their main meal later. The obvious explanation for these findings would just be that those who eat later also tend to eat more, and there does seem to be a relationship between when people eat most of their calorie intake and how many calories they end up eating over the entire day, with those eating a greater proportion in the morning, eating less overall. Maybe later eaters are just overeating junk on the couch watching primetime TV. A tendency has been found for night owls to eat more fast food, soda, fewer fruits and vegetables. In the field of social psychology, there's a controversial concept called ego depletion, where self-control is viewed as a limited resource like a muscle that can become fatigued from overuse. As the day wears on, the ability to resist unhealthy food choices may decline, leaving one vulnerable to temptation. So, is it just a matter of later eating leading to greater eating? Remember this study where earlier eaters steadily lost more weight? To their surprise, the early eaters were eating as much as the late eaters, despite the difference in weight loss magnitude. The early eaters ended up about 5 pounds lighter than the late eaters by the end of the 20-week study, even though they were apparently eating the same amount of food. There didn't seem to be any difference in physical activity between the two groups either. Could it be that just the timing itself of calorie intake matters? Scientists decided to put it to the test, which we'll cover next. Mice are nocturnal creatures. They eat during the night and sleep during the day. If, however, you just feed mice during the day, they gain more weight than if you feed them a similar amount of calories at night. Same food, about the same amount of food, but different weight outcomes, suggesting that eating at the wrong time may lead to disproportionate weight gain. In humans, that would presumably mean eating at night. Weight management recommendations often include advice to limit nighttime food consumption, but this was largely anecdotal until it was first studied experimentally in 2013. Researchers instructed a group of young men to not eat after 7 p.m. for 2 weeks, compared to a control period where they continued their regular habits. After the night eating restriction, they ended up about 2 pounds lighter. This is not surprising, given that dietary records show they inadvertently ate fewer calories during that time. To see if timing has metabolic effects beyond just foreclosing eating opportunities, you'd have to force people to eat the same amount of the same food, just at different times of the day. The U.S. Army stepped forward to carry out just such an investigation. In the first set of experiments, Army researchers had people eat a single meal a day, either as breakfast or as dinner. The results clearly showed that the breakfast group lost more weight. Check it out. Have people eat only once a day at dinner, and their weight doesn't change much. Have them eat once a day at breakfast, and they lose about 2 pounds a week. Like in the night eating restriction study, this is to be expected, right? Given that people tend to be hungrier in the evening. Think about it. And if you went 9 hours without eating during the day, you'd be famished, right? But people go 9 hours overnight all the time, and don't wake up ravenous, right? There's a natural circadian rhythm to hunger that peaks about 8 p.m. and drops down to its lowest level at about 8 a.m. Right? That may be why breakfast typically is the smallest meal of the day. The circadian rhythm of our appetite isn't just behavioral, it's biological. It's not just that we're hungry in the evening because we've been running around all day. If you stayed up all night and slept throughout the day, you'd still be hungriest when you woke up that evening. To untangle the factors, scientists use what's called forced desynchrony protocols, where they lock people up in a room without windows and a kind of constant, unchanging dim light, and make people sleep in staggered 20-hour cycles to totally scramble them up. Right? That goes on for a week, so the study subjects end up eating and sleeping at different times throughout all phases of the day. Right? Then you can see if cyclical phenomena are truly based on internal clocks, or just a consequence of what you happen to be doing at the time. For instance, there's a daily swing in our core temperature, and blood pressure, and hormone production, and digestion, and immune activity, and almost everything else. But let's use temperature as an example. Your body temperature bottoms out usually around 4 a.m., dropping from 98.6 down to more like 97.6. Now, is this just because your body cools down as you're sleeping? No. You can show experimentally by keeping people awake and busy for 24 hours straight that it happens at about the same time, no matter what. It's part of our circadian rhythm, just like our appetite. Right? It makes sense, then, if you're only eating one meal per day and you want to lose weight, you'd want to eat in the morning when your hunger hormones are at their lowest level. OK, but then things start to get weird. The Army scientists repeated the experiment, but this time they had the participants eat exactly 2,000 calories, either as breakfast or as dinner. Right? That takes appetite out of the picture. Right? They were also not allowed to exercise. Same number of calories, so same change in weight, right? No, the breakfast-only group still lost about 2 pounds a week compared to the dinner-only group. 2 pounds of weight loss, eating the same number of calories. That's why this concept of chronobiology, meal timing, when to eat, is so important. Garlic lowers blood pressure, regulates cholesterol, and stimulates immunity. I've talked about the heart disease risk factors. What about the immunity? Eating garlic appears to offer the best of both worlds, dampening the overactive phase of the immune system by suppressing inflammation, while boosting protective immunity, for example, natural killer cell immunity, which our body uses to purge cells that have been stricken by viruses or cancer. In World War II, garlic was evidently dubbed Russian penicillin because, after running out of antibiotics, that's what the Soviet government turned to. But does it actually work? You don't know until you put it to the test. For example, how about preventing the common cold, perhaps the world's most widespread viral infection, with most people suffering approximately 2 to 5 colds per year? The first double-blind, placebo-controlled trial to investigate the prevention of viral disease with a garlic supplement. Those randomized to the garlic suffered 60% fewer colds, 70% fewer days affected, so not only fewer colds, but faster recovery, suffering only 1.5 days instead of 5. So accelerated relief, reduction in symptom severity, faster recovery to full fitness. OK, but this study was done nearly 20 years ago. What about all the other randomized controlled trials? There aren't any. Just that one trial to date, but still. And the best available balance of evidence then suggests that garlic may indeed prevent occurrences of the common cold. The common cold is one thing, but what about cancer, right? Is it a stake through the heart of cancer? Various garlic supplements have been tested on cells in a petri dish or lab animals, but there were no human studies to see if garlic could affect gene expression until now. Eat one big clove of crushed raw garlic, and within hours, you get an alteration of the expression of your genes related to anti-cancer immunity. It's one thing to see a big boost in production of cancer-suppressing proteins like oncostatin when you drip garlic directly on cells in a petri dish, but you also see boosted gene expression directly in your bloodstream within hours of eating it. Does this then translate into lower cancer risk? 10 population studies put together, and those reporting higher consumption of garlic only had half the risk of stomach cancer. How do you define high? In each study, it was different, from a few times a month to every day, but regardless, those who ate more appeared to have lower cancer rates than those who ate less, suggesting a protective effect. And hey, stomach cancer is a leading cause of cancer-related death around the world, while garlic is relatively cheap, widely available, and easy to incorporate into your daily diet in a safe manner, and perhaps the more the better. The only way to prove garlic can prevent cancer, though, is to put it to the test. Thousands of individuals were randomized to receive 7 years of a garlic supplement or a placebo, and they did tend to get less cancer and die from less cancer, but the findings were not statistically significant, meaning they could have just happened by chance. Why didn't we see a more definitive result, given that garlic eaters appear to have such lower cancer rates? Well, they didn't give them garlic, they gave them garlic extract and oil pills, and it's possible some of the purported active components weren't preserved in supplement form. One study of garlic supplements found that it might take up to 27 capsules to obtain the same amount of garlic goodness found in just a half clove of crushed raw garlic. What happens if you cook it? If you compare raw chopped garlic to garlic simmered for 15 minutes, boiled for 6, or stir-fried for just 1 minute, you can get a threefold drop in one of the purported active ingredients called allicin when you boil it, even more if you simmer it for too long, and it all seems to get wiped out by even the minute of stir-frying. What about roasted garlic? Surprisingly, even though roasting is hotter than boiling, it preserved about twice as much. Raw has the most, but it may be easier for some folks to eat 2 or 3 cloves of cooked garlic than even a half clove of raw. What about pickled garlic, or those jars of minced garlic packed in water, or packed in oil, or that fancy fermented black garlic? Though jarred garlic may be more convenient, there is comparably less garlicky goodness, especially pickled garlic, and the black garlic really falls far behind. Can you eat too much? The garlic meta-analysis suggests there's no real safety concerns with side effects or overdosing, though that's with internal use. You should not stick crushed garlic on your skin. It can cause irritation, and if left on long enough, can actually burn you. Wrap your knees with a garlic paste bandage, or stick some on your back overnight, and you can end up like this, or this. Definitely don't rub garlic on babies. But an article online said that topical garlic was good for respiratory disorders, and the girl was congested. Look at those blisters. Oh, the poor pumpkin. Right? Natural does not necessarily mean safe. Right? Don't put it on your toes. Don't use it as a face mask. Don't use it to try to get out of military service. But when you instead just eat it like you're supposed to, there shouldn't be a problem, though some people do get an upset tummy if they eat a little too much. And look, you really can't say no side effects given the body odor and garlic breath. In my last chronobiology video, we learned that the exact same number of calories at breakfast are significantly less fattening than the same number of calories eaten at supper. But who eats just 1 meal a day? What about just shifting our daily distribution of calories earlier in the day? Israeli researchers randomized overweight and obese women into one of two isocaloric groups, meaning each group was given the same number of total calories. One group was given a 700-calorie breakfast, a 500-calorie lunch, and a 200-calorie dinner, and the other group was given the opposite, 200 for breakfast, 500 for lunch, and 700 for dinner. Since they were all eating the same number of calories overall, the King Prince Pauper group should have lost the same amount of weight as the Pauper Prince King group, right? But no, the morning slanted group lost more than twice as much weight. In addition to slimming about an extra 2 inches off their waistlines, by the end of the 12-week study, the King Prince Pauper group lost 11 more pounds, 19 pounds lost compared to 8, despite eating the same number of calories. That's the power of chronobiology, the power of our circadian rhythms. 700, 500, 200. It's 50% of calories at breakfast, 36% of calories at lunch, and only 14% of calories at supper. That's pretty skewed. What about 20% for supper instead? A 50%, 30%, 20% spread compared to 20, 30, 50. Again, the bigger breakfast group experienced dramatically increased weight loss, about 9 pounds different in just 8 weeks, right? With no significant differences in overall calorie intake or physical activity between the two groups. Instead of 80% plus of calories at breakfast and lunch, what about 70% compared to 55%? Overweight homemakers were randomized to eat 70% of their calories at breakfast, a morning snack, and lunch, leaving 30% for an afternoon snack and dinner, or more balanced 55% up through and including lunch. In both cases, only a minority of calories were eaten for dinner. I mean, would it matter if it was just 55% up through lunch or 70%? Yes, significantly more weight loss and slimming in the dietary pattern that was even more biased towards the morning. Stories about food and nutrition are in the news on an almost daily basis, but information can sometimes be confusing and contradictory. Clear messages should be proposed in order to reach the greatest number of people, the researchers conclude, and one clear communication physicians could give is, if you want to lose weight, eat more in the morning than in the evening. Even just telling people to eat their main meal at lunch rather than dinner may help, despite comparable caloric intake. Participants in a weight loss program randomized to get advice to make their main meal lunch beat out those who instead were told to make their main meal dinner. The proverb, eat breakfast like a king, lunch like a prince, and dinner like a pauper, evidently has another variant. Eat breakfast yourself, share lunch with a friend, and give dinner away to your enemy. Wouldn't go that far, but there does appear to be metabolic benefit to front-loading the bulk of your calories earlier in the day. The evidence isn't completely consistent, though. A review of dietary pattern studies questioned the role that reducing evening intakes would facilitate weight loss, citing this study that showed the evening-weighted group did better than the heavy morning meal group. Perhaps that was because the morning meal group was given for breakfast chocolate cookies, cake, ice cream, chocolate mousse, and donuts. Right? So chronobiology can be trumped by a junk food methodology. Overall, the what is still more important than the when. Caloric timing may be used to accelerate weight loss, but doesn't substitute for a healthy diet. When he said that there was a time for every purpose under heaven, Ecclesiastes probably wasn't talking about donuts. Why are calories eaten in the morning apparently less fattening than calories eaten in the evening? One reason that more calories are burned off in the morning due to diet-induced thermogenesis. That's the amount of energy the body takes to digest and process a meal, given off in part as waste heat. If you take people and give them the exact same meal in the morning, afternoon, and night, their body uses up about 25% more calories to process it in the afternoon than night, and about 50% more calories to digest it in the morning. That leaves fewer net calories in the morning to be stored as fat. Let's put some actual numbers to it. A group of Italian researchers randomized 20 people to eat the same standardized meal at 8 a.m. or 8 p.m., and then a week later had them all come back to do the opposite. So each person had the chance to eat the same meal for breakfast and for dinner. After each meal, the subjects were placed in a calorimeter contraption to precisely measure how many calories they were burning over the next 3 hours. The researchers calculated that the meal given in the morning took about 300 calories to digest, whereas the same meal given at night used up only about 200 calories to process. The meal was about 1,200 calories, but given in the morning, it ended up only providing about 900 calories compared to more like 1,000 calories at night. Same meal, same food, same amount of food, but effectively 100 fewer calories. So a calorie is not just a calorie, it depends on when we eat them. Why do we burn more calories eating a morning meal? I mean, is it behavioral or biological? If you started working the graveyard shift, sleeping during the day and working at night, which meal would net you fewer calories? Would it be the breakfast you had at night before you went to work, or the supper you had in the morning before you went to bed? In other words, is it something about just eating before you go to sleep that causes your body to hold on to more calories? Or is it built in to our circadian rhythm, where we store more calories at night regardless of what we're doing? You don't know until you put it to the test. Harvard researchers randomized people to identical meals at 8 a.m. versus 8 p.m., while under simulated night shifts or day shifts, and regardless of activity level or sleeping cycle, the calories burned processing the morning meals was 50% higher than the evening. So the difference is explained by chronobiology. It's just part of our circadian rhythms to burn more meal calories in the morning. But why? I mean, what exactly is going on? How does it make sense for our body to waste calories in the morning when we have the whole day ahead of us? Right? Our body isn't so much wasting calories as investing them. See, when we eat in the morning, our body bulks up our muscles with glycogen, which is the primary energy reserve our body uses to fuel our muscles. But this takes energy. In the evening, our body expects to be sleeping for much of the next 12 hours, so rather than storing blood sugar as extra glycogen in our muscles, it preferentially uses it as an energy source, which may end up meaning we burn less of our backup fuel, which is body fat. In the morning, however, our body expects to be running around all day, so instead of just burning off breakfast, our body continues to dip into our fat stores while we use breakfast calories to stuff our muscles full of the energy reserves we need to move around over the course of the day. That's where the inefficiency may come from. The reason it costs more calories to process a morning meal is because instead of just burning glucose, blood sugar, directly, our bodies are instead using up energy to string glucose molecules together into chains of glycogen in our muscles, which are then just going to be broken back down into glucose later in the day. That extra assembly-disassembly step takes energy that your body takes out of your meal, leaving you with fewer calories. So in the morning, our muscles are especially sensitive to insulin, rapidly pulling blood sugar out of our bloodstream to build up glycogen reserves. At night, though, our muscles become relatively insulin resistant. Our muscles resist the signal to take in extra blood sugar. So does that mean you get a higher blood sugar and insulin spike in the evening compared to eating the exact same meal in the morning? Yes. In that 100-calorie difference study, for example, blood sugars rose twice as high after the 8 p.m. meal compared to the same meal in the morning. So shifting the bulk of our calorie intake towards the morning would appear to have a dual benefit: more weight loss and better blood sugar control. In 2010, the first controlled trial was published, examining how the brain responds to grape juice. It helped aged rats, but what about people? Concord grape juice supplementation improves memory function in older adults with mild cognitive impairment, or so says the title. The problem is that the study was funded by Welch's, and though the authors claim they have no financial interest in the outcome, that seems disingenuous. I mean, do you think Welch's would ever fund them again if they found that grape juice wasn't good for you? And indeed, that title is a bit of industry spin. I'm sure that's what they wanted to find. Older adults with memory decline, but not dementia, were randomized into a placebo-controlled double-blind trial with Concord grape juice, versus same calorie, same sugar, similarly looking, tasting grape Kool-Aid type drink. So it's a solid study design, and look, berries have those wonderful polyphenol phytonutrients, which have anti-inflammatory and antioxidant properties, so it certainly could help brain function. And it did seem to help with verbal learning. The chances you'd get such a notable result just by chance is like 1 in 25. Whereas the higher recall scores are considered not statistically significant, since even if there wasn't an effect, you might get those kind of results by chance 1 in every 8 or 10 times you'd run the experiment. And by convention, we really like to see at least 1 in 20, so a p-value of 0.05 or less, especially if you're looking at multiple outcomes, which increases the likelihood that something will just kind of pop up as a fluke. Bottom line is that we're less confident in those kind of memory outcomes, so I imagine if this hadn't had industry funding, it would have been titled more accurately, Concord grape juice supplementation improves verbal learning in older adults with mild cognitive impairment, which is still an important finding, and we have the Welch's Corporation to thank for it. And without industry funding, a study like this might never get done. The findings suggest that drinking grape juice is superior to drinking grape Kool-Aid, not necessarily for memory, but maybe for helping with learning. When the study was repeated, though, it did seem to help one measure of memory, but found no benefit for verbal learning, even when using the exact same test as before, which calls the previous results into question. So we're left uncertain about what effects, if any, grape juice has on the aging brain. What about the brains of middle-aged mothers? The Welch's-funded researchers noted significant improvements in one measure of memory and driving performance, as measured in some fancy driving simulator, suggesting on grape juice you might be able to stop 12 yards earlier on the highway than if you had instead been drinking grape Kool-Aid. I do like how they tried to translate the cognitive effects into more meaningful metrics, but it's important to acknowledge, as they did, that no effects were found for the majority of cognitive consequences. And when you study 20 different outcomes, the odds are pretty good you're just going to get a statistically significant result or two by chance. The latest study involved a single dose given to young adults, average age 21, a cup of purple grape juice, or white grape juice, to which flavor and color had been added to disguise it. In this way, you could see if there's something special about those deep purple polyphenol pigments in Concord grape juice, and got the same kind of results, 2 cognitive measures just reaching statistical significance. But that's out of 7 different outcomes. So instead of 0.05 as the cutoff for significance, we'd really like to see closer to 0.007, and none hit that. Maybe it's because they didn't use the whole food, like in that blueberry study I profiled before. There was a study that looked at actual grape consumption by utilizing freeze-dried grape powder to capture the kind of whole food instead of just the juice, versus a sugar-matched placebo. They used PET scans to track changes in brain metabolism associated with early Alzheimer's in a group of older adults already suffering from mild cognitive decline. Although the changes couldn't be picked up on neuropsych testing, in those early-stage Alzheimer's regions, the placebo group continued to worsen, but the grape group was spared such decline, suggesting a protective effect of grapes. Here's that in kind of graph form, showing the significant differences, or even better, brain mapping pictures. Here's one of the placebo brains. The red areas indicate locations where brain metabolism declined after 6 months of eating placebo grapes. Compare that level of decline to a brain that ate 6 months of actual grapes. We've known for more than a half-century now that our glucose tolerance declines as the day goes on, meaning the ability of your body to keep blood sugars under control. If you hook yourself up to an IV and just drip sugar water into your vein at a steady pace throughout the day, At about 8 p.m., your blood sugars start to go up, even though you haven't eaten anything and the infusion rate didn't change. The same amount of sugar is going into your system every minute, but your ability to handle it deteriorates in the evening, but bounces right back in the morning. A meal eaten at 8 p.m. Can cause twice the blood sugar response as an identical meal eaten at 8 a.m. It's as if you weighed twice as much. Your body just isn't expecting you to be eating when it's dark outside. Our species may have only discovered how to use fire about 250,000 years ago. We just weren't built for 24-hour diners. One of the tests for diabetes is called the glucose tolerance test, to see how fast your body can clear sugar from your bloodstream. You swig down a cup of water with about 4.5 tablespoons of regular corn syrup mixed in, and then have your blood sugar measured 2 hours later. By that point, your blood sugar should be under 140 milligrams per deciliter. Between 140 and 199 is considered prediabetes, and 200 and up is a sign of full-blown diabetes. The circadian rhythm of glucose tolerance is so powerful that a person can test normal in the morning, but is a pre-diabetic later in the day. Pre-diabetics who average 163 at 7 a.m. test out as frank diabetics by 7 p.m. at over 200. Choosing lower glycemic foods may help promote weight loss, but timing is critical. Due to this circadian pattern of glucose tolerance, a low glycemic food at night can cause a higher blood sugar spike than a high glycemic food eaten in the morning. We're so metabolically crippled at night, researchers found that eating a bowl of All-Bran at 8 p.m. caused as high a blood sugar spike as eating Rice Krispies at 8 a.m. High glycemic foods at night would seem to be the worst of both worlds. So if you're going to eat refined grains and sugary junk, it might be less detrimental in the morning. The drop in glucose tolerance over the day could therefore help explain the weight loss benefits of front-loading calories towards the beginning of the day. Even just an earlier versus later lunch may make a difference. People randomized to eat a large lunch at 4:30 p.m. suffered a 46% greater blood sugar response compared to the identical meal eaten just a few hours earlier at 1 p.m. And a meal at 7 a.m. Can cause 37% lower blood sugars than an identical meal at 1 p.m. Now, there doesn't seem to be any difference between a meal at 8 p.m. and the same meal at midnight. They both seem to be too late, but eating that late, at midnight or even 11 p.m., can so disrupt your circadian rhythm that can mess up your metabolism the next morning, resulting in significantly higher blood sugars after breakfast, compared to eating the same supper at 6 p.m. the evening before. So these revelations of chronobiology bring the breakfast debate full circle. Breakfast skipping not only generally fails to cause weight loss, but worsens overall daily blood sugar control in both diabetic and non-diabetic individuals. See how the breakfast skippers have higher blood sugars even while they're sleeping 20 hours later? That may help explain why those who skip breakfast appear to be at higher risk of developing type 2 diabetes in the first place. Breakfast skippers also tend to have higher rates of heart disease and atherosclerosis in general. Is it just because breakfast skipping tends to cluster with other unhealthy choices, such as smoking and sicklier eating habits overall? The link between breakfast skipping and heart disease, even premature death in general, seems to survive attempts to control for these confounding factors. But you don't know until you put it to the test. Does skipping breakfast lead to higher cholesterol, for example? Yes, significant rise in LDL bad cholesterol in those randomized to skip breakfast, about 10 points higher within just 2 weeks. The Israeli 700, 500, 200 study found that the triglycerides of the King Prince Pauper group got significantly better, a 60-point drop, while those on the Pauper Prince King group got significantly worse, a 26-point rise. So consuming more calories in the morning relative to the evening may actually have a a triple benefit, right? More weight loss, better blood sugar control, and lower heart disease risk. So if you're going to skip any meal, whether practicing intermittent fasting or time-restricted feeding, where you try to fit all your food into a certain daily time window, it would be safer and more effective, perhaps, to skip dinner rather than breakfast. One of the most important breakthroughs in recent years has been the discovery of peripheral clocks. We've known about the central clock, the so-called suprachiasmatic nucleus, for decades. It sits in the middle of your brain, right above where your optic nerves cross, allowing it to respond to night and day. Now we know there are semi-autonomous clocks in nearly every organ in our body. Our heart runs on a clock, our lungs run on a clock, our kidneys run on a clock. Up to 80% of the genes in our liver are expressed in a circadian rhythm. Our entire digestive tract does too. The rate at which our stomach empties, the secretion of digestive enzymes, and the expression of transporters in our intestinal lining for absorbing sugar and fat all cycle around the clock. So too does the ability of our body fat to sop up extra calories. The way we know these cycles are driven by local clocks rather than being controlled by our brain, so you can take surgical biopsies of fat, put them in a petri dish, and still watch them rhythm away. All this clock talk is not just biological curiosity. Our health may depend on keeping all these clocks in sync. You think about it like a child playing on a swing. Imagine you're pushing, but you become distracted by other goings-on in the playground and stop paying attention to your timing. So you forget to push, or push too early, push too late. What happens? Out of sync, the swinging becomes erratic, slows, or even stops. Right? That's what happens when we travel across multiple time zones or have to work the night shift. The pusher, in this case, are the light cues falling on our eyes. Our circadian rhythm is meant to get a bright light push every morning at dawn, but if the sun rises at a different time, or we're exposed to bright light in the middle of the night, this can push our cycle out of sync and leave us feeling out of sorts. Right? That's an example of a mismatch between the external environment and our central clock. Problems can also arise from a misalignment between the central clock in our brain and all the other organ clocks throughout our body. An extreme illustration of this is a remarkable set of experiments suggesting even our poop can get jet lag. Our microbiome seems to have its own circadian rhythm. Even though they're down where the sun don't shine, there's a daily oscillation in both bacterial abundance and activity in our colon. Interesting, but who cares? Check this out. If you put people on a plane and fly them halfway around the world, then feed their poop to mice, they grow fatter than mice fed pre-flight feces, though it may have just been bad airline food or something. The researchers suggest the fattening flora was a consequence of circadian misalignment. Right? Indeed, several lines of evidence now implicates chronodisruption, the state in which our central and peripheral clocks diverge out of sync as playing a role in conditions ranging from premature aging and cancer to mood disorders and obesity. Bright light exposure is the synchronizing swing pusher for our central clock. Well, what drives our internal organ clocks that aren't exposed to daylight? Food intake. That's why the timing of our meals may be so important. Removing all external timing cues by locking people away under constant dim light, researchers showed you could effectively decouple central from peripheral rhythms just by shifting meal times. They took blood draws every hour and even took biopsies of their fat every 6 hours to demonstrate the resulting metabolic disarray. Just as morning light can help sync your central clock in your brain, morning meals can help sync your peripheral clocks throughout the rest of your body. Breakfast skipping disrupts the normal expression and rhythm of these clock genes themselves, which coincides with the adverse metabolic effects. Thankfully, they can be reversed. Take a group of habitual breakfast skippers and have them eat 3 meals at 8 a.m., 1 p.m., 6 p.m., and their cholesterol triglycerides improves compared to taking meals 5 hours later at 1 p.m., 6, and 11 p.m. See, there's a circadian rhythm to cholesterol synthesis in the body too, which is also strongly influenced by food intake, as evidenced by the 95% drop in cholesterol production in response to a single day of fasting. That's why just a few-hour shift in meal timing can result in a 20-point drop in LDL cholesterol, thanks to eating earlier meals. The number one killer in the United States and around the world is what we eat, killing millions more than tobacco, for example. What are the 5 most important things we can do to improve our diets, based on the single most comprehensive global study of the health impact of nutrition? Eat less salt, eat more nuts, eat more non-starchy vegetables, and more fruit, and finally, eat more whole grains. Any particular type of whole grains? What about so-called ancient grains? Are they any better than modern varieties? Like what about kamut, the so-called mummy wheat, supposedly unearthed from an Egyptian tomb? After World War II, the wheat industry selected particularly high-yielding varieties for pasta and bread. Over the past few years, though, some of the more ancient varieties have been reintroduced on the market, defined basically as those that haven't changed over the agricultural revolutions of the last century. Nutritionally, einkorn wheat, the oldest wheat, and kamut have more of the eyesight-improving yellow carotenoid pigments like lutein and zeaxanthin, compared to modern bread and pastry wheat, because the pigments have been bred out of the bread intentionally. People want their white bread white, but modern pasta flour, durum wheat, maintains much of that yellow hue nutrition. Yes, modern wheat may have less lutein, but, for example, tends to have more vitamin E, based on straight vitamin and mineral concentrations. I mean, it's pretty much a wash. They both have lots of each, but the primitive wheats do have more antioxidant capacity, likely due to their greater polyphenol content, but to know if this makes any difference, you have to put it to the test. If you expose human liver cells to digested bread made out of ancient grains, kamut and spelt, heritage wheat, or modern strains, and then expose the cells to an inflammatory stimulus, the modern wheat strains seem less able to suppress the inflammation. The investigators conclude that, despite the fact that these different grains seem to be very similar nutritionally, they seem to exert different effects on human cells, confirming the potential health benefits of ancient grains. But this was in a Petri dish. What about in people? If ancient wheats are better at suppressing inflammation, what if you took people with irritable bowel syndrome and randomized them to receive 6 weeks of wheat products made out of the ancient wheat kamut, in this case, or modern wheat? Same amount of wheat, just different types. If there's no difference between the wheats, there'd be no difference in people's symptoms, right? But check this out. Here's how the control groups did on the modern wheat. Switched to the kamut, they experienced less abdominal pain, less frequent pain, less bloating, more satisfaction with stool consistency, and less interference with their quality of life. So after switching to the ancient grain, patients experienced a significant global improvement in the extent and severity of symptoms related to their irritable bowel. What about liver inflammation, the liver function of those with non-alcoholic fatty liver disease, randomized to eat kamut, improved compared to those eating the same amount of regular wheat, suggesting kamut is superior. In diabetics, better cholesterol and insulin sensitivity on the same ancient grain. In those with heart disease, better blood sugar control, and better cholesterol, better artery function in those without overt heart disease. The bottom line is findings derived from human studies suggest that ancient wheat products are more anti-inflammatory and improve things like blood sugar control and cholesterol. Given that the overall number of human interventional trials is still small, it's not possible to definitively conclude that ancient wheat varieties are superior to all commercial modern wheat counterparts in reducing chronic disease risk, but the best available data does suggest they're better if you have the choice. Regardless of what type of wheat you eat, word to the wise, don't eat the plastic bread bag clip. 45-year-old guy presents with bloody stools, and this is what their CT scan looked like. Later questioned, the patient admitted to habitually eating quickly without chewing properly. Shift workers may have higher rates of death from heart disease, stroke, diabetes, dementia, cardiovascular disease, and cancer. Graveyard shift, indeed. But is this just because they're eating out of vending machines or not getting enough sleep? Highly controlled studies have recently attempted to tease out these other factors by putting people on the same diets, with the same sleep, but just at the wrong time of the day. Redistributing eating to the nighttime resulted in elevated cholesterol, blood pressure, and inflammation. No wonder shift workers are at higher risk. Shifting meals to the night in a simulated night shift protocol turned about a third of the subjects effectively pre-diabetic in just 10 days. Our bodies just weren't designed to handle food at night. Just as avoiding bright light at night can prevent circadian misalignment, so can avoiding night eating. We may have no control over the lighting at our workplace, but we can try to minimize overnight food intake, which has been shown to help limit the negative metabolic consequences of shift work. When we finally do get home in the morning, though, we may disproportionately crave unhealthy food. In this experiment, 81% of participants in a night shift scenario chose high-fat foods such as croissants out of a breakfast buffet, compared to just 43% of the same subjects during a control period on a normal schedule. Shift work may also have people too fatigued to exercise, but even at the same physical activity levels, chronodisruption can affect energy expenditure. Researchers found that you burn 12 to 16% fewer calories while sleeping during the daytime compared to night. Just a single improperly timed snack can affect how much fat you burn every day. Study subjects eating a specified snack at 10 a.m. burned about 6 grams more fat from their body than on the days they ate the same snack at 11 p.m. It's only about a pat and a half of butter's worth of fat, but it was the identical snack, just given at a different time. The late snack group also suffered about a 9% bump in their LDL cholesterol within just 2 weeks. Even just sleeping in on the weekends may screw up our metabolism. Social jet lag is the discrepancy in sleep timing between our work days and our free days. From a circadian rhythm standpoint, when we go to bed late and sleep in on the weekends, it's as if we flew a few time zones west on Friday evening and fly back on Monday morning. Travel-induced jet lag goes away in a few days, but what might the consequences be of constantly shifting your sleep schedule every week over your entire working career? Interventional studies have yet to put it to the test, but population studies suggest that those who have at least an hour of social jet lag a week, which may describe more than 2/3 of people, have twice the odds of being overweight. If sleep regularity is important, what about meal regularity? The importance of regular meals at roughly the same time every day was evidently emphasized by such luminaries as Hippocrates and Florence Nightingale, but wasn't put to the test until the 21st century. A few population studies had suggested that those eating meals irregularly were at a metabolic disadvantage, but the first interventional studies weren't published until 2004. Subjects were randomized to either regular diets split up into 6 regular eating occasions a day or 3 to 9 a day in an irregular manner. Researchers found that eating an irregular pattern of meals every day can cause a drop in insulin sensitivity and cause cholesterol levels to rise and reduce the calorie burn immediately after meals in both lean and obese individuals. They ended up eating more, though, on the irregular meals, and so it's difficult to disentangle the circadian effects. The fact that overweight individuals may overeat on an irregular pattern may be telling in and of itself, but it would be nice to see such a study repeated using identical diets to see if irregularity itself has metabolic effects. And just such a study was published in 2016, during 2 periods. People were randomized to eat identical foods in regular or irregular meal patterns. During the irregular period, people had impaired glucose tolerance, meaning higher blood sugar responses to the same food, and lower diet-induced thermogenesis, meaning burned fewer calories to process each meal. The difference in thermogenesis only comes out to be about 10 calories per meal, and indeed there was no difference in weight changes over the 2-week periods. But diet-induced thermogenesis can act as a satiety signal. The extra work put into processing meal can help slake one's appetite. And indeed, lower hunger and higher fullness ratings during the regular meal period could potentially translate into better weight control over the long term. If weakening our circadian rhythm can cause weight gain, might strengthening it facilitate weight loss? In our child swing analogy, regular morning meals can give our cycles a little daily push, but the biggest shove comes from our exposure to bright morning light. Similarly, exposure to light at night could be analogous to nighttime eating. Yes, we've had candles to illuminate our nights for 5,000 years, but flames from candles, campfires, and oil lamps are skewed towards the red end of the light spectrum, and it's the shorter blue wavelengths that specially set our circadian clocks. Even incandescent electric lighting, starting a little over a century ago, consisted of mainly low-level yellow wavelengths, replaced over just the last few decades with fluorescence and LED lights that now contain extra blue wavelengths, which is more similar to morning sunlight and has the strongest effect on our circadian rhythms. Using wrist meters to measure ambient light exposure, researchers found that increased evening and lighttime exposure correlated with a subsequent increased risk of developing obesity over time. This was presumed to be due to circadian misalignment, but maybe instead a sign that they're not sleeping as much. Maybe that's the real reason they grew heavier. This was controlled for in a study of more than 100,000 women, which found that the odds of obesity trended with higher nighttime light exposure, independent of sleep duration. Compared to women who reported their rooms at night were too dark to see their hand in front of their face, or at least too dark to see across the room, those who reported that it was light enough to see across their bedrooms at night were significantly heavier. It's not that they were all sleeping with their night lights on. Without blackout curtains on the windows, many neighborhoods may be bright enough to cause circadian disruption. Using satellite imagery, scientists have even been able to correlate higher obesity rates with brighter communities. There's so much light at night these days that outside of a blackout, the only Milky Way our children will likely ever see is in a candy wrapper. Although sleep quantity could be controlled for, what about sleep quality? Maybe people sleeping in less dim bedrooms don't sleep as soundly, leaving them too tired to exercise the next day or something. You can't know for sure if nocturnal light exposure is harmful in and of itself until you put it to the test. When that was done, those randomized to exposure to bright light for a few hours in the evenings, or even a single night, suffered adverse metabolic consequences. The more intriguing question then becomes, can circadian syncing with morning bright light therapy be a viable weight loss strategy? Insufficient morning light may be the circadian equivalent of breakfast skipping. Indoor lighting is too bright at night, but maybe too dim in the day to robustly boost our daily rhythm. Light exposure from getting outdoors in the morning, even on overcast days, is correlated to lower body weight compared to typical office lighting, so some doctors started trying phototherapy to treat obesity. The first case reports started to be published back in the 90s. 3 out of 4 women lost an average of about 4 pounds over 6 weeks of morning bright light exposure, but there was no control group to confirm the effect. 10 years later, the first randomized controlled trial was published. Overweight individuals were randomized to an exercise intervention with or without an hour a day of bright morning light. Compared to normal indoor lighting, the bright light group lost more body fat. But it's possible the light just stimulated them to exercise harder. Studies show that bright light exposure, even the day prior to exercise, may boost performance. In a hand grip endurance test, exposure to hours of bright light increased the number of contractions until exhaustion from about 770 to 860 the next day. While light-induced improvements in activity or mood can be helpful in their own right, it would be years later still before we finally learned whether the light exposure itself could boost weight loss. Following an unpublished study in Norway purporting to show a dozen-pound weight loss advantage to 8 weeks of 30 minutes of daily daylight compared to indoor lighting, researchers tried 3 weeks of 45-minute morning bright light compared to the same time sitting in front of a quote-unquote ion generator that appeared to turn on but was secretly deactivated. The 3 weeks of light beat out the placebo, but the average difference in body fat reduction was only about a pound. The slight edge didn't seem to correlate with mood changes, but bright light alone can stimulate serotonin production in the human brain and cause a release of adrenaline-type hormones, both of which could benefit body fat aside from any circadian effects. Regardless of the mechanism, bright morning daylight exposure could present a novel weight loss strategy straight out of the clear blue sky. SAD doesn't just stand for Standard American Diet. There's a condition known as seasonal affective disorder that's characterized by increased appetite and cravings, along with increased sleepiness and lethargy that begins in autumn when light exposure starts to dwindle. This now appears to just represent the far end of a normal spectrum of human behavior. We all appear to eat more as the days get shorter. There's a marked seasonal rhythm to calorie intake with greater meal size, eating rate, hunger, and overall calorie intake in the fall. In preparation for winter, some animals hibernate, doubling their fat stores with autumn abundance to deal with the subsequent scarcity of winter. Genes have been identified in humans that are similar to hibernation genes, which may help explain why we exhibit some of the same behaviors. The autumn effect isn't subtle. Researchers calculated a 222-calorie difference between calorie intake in the fall versus spring. And this isn't just because it's colder. Since we eat more in the fall than the winter, it appears we're just genetically programmed to prep for the deprivation of winter that no longer comes. It's remarkable that in this day and age of modern lighting and heating that our bodies would still pick up on environmental cues of the changing seasons enough to affect such major influence on our eating patterns. Unsurprisingly, bright light therapy is used to treat seasonal affective disorder, nearly tripling the likelihood of remission compared to placebo. Though it's never been directly tested, it can't hurt to take the dog out for some extra autumn morning walks to maybe help fend off some of the coming holiday season weight gain. It's funny, people blame the holidays for overeating, but maybe instead of the holidays causing heightened intake, maybe the heightened intake that goes with the fall caused the holidays to be scheduled then in the first place. Regardless, other specific recommendations for the prevention of obesity by improving the circadian system health based on varying degrees of evidence include sleeping during the night and being active during the day. Sleep enough, at least 7 or 8 hours a night, early to bed, early to rise. Short naps are fine. Contrary to popular belief, daytime napping does not appear to adversely impact sleep at night. Avoid bright light exposure at night, and sleep in total darkness when possible. Make breakfast or lunch your biggest meal of the day. Don't eat or exercise right before bed, and avoid eating at night completely. There's been a recognition that cigarette smoking can have a major effect on bone health for decades, increasing the lifetime risk of hip fracture by about half. It also appears to impair bone healing, so much so that surgeons ask if they should be discriminating against smokers because the bone and wound healing complication rates are just so high. But what about smoking marijuana? There is accumulating evidence to suggest that cannabis compounds play important roles regulating bone mass and bone loss. Yeah, but are they friend or foe?
Results from research on cannabis compounds and bone mineral density in rodent models have been inconsistent. Some studies show increased bone formation, others show increased bone loss, and others show no association at all. This variation in results may be due in part to differences in the mouse strain used. But if you can't even extrapolate from one mouse to another, how can you extrapolate to human beings? So what if you just measure cannabis use and bone mineral density in people? Thousands of adults were tested and asked about their cannabis use, and there did not appear to be any link between the two. That's a relief, though in this study, heavy cannabis use was defined as just 5 days or more of use in the last month. They didn't ask beyond that. So theoretically, someone who's just smoked 5 joints in their entire life could be categorized as a heavy user. How about cannabis use on 5,000 separate occasions over a lifetime? Now that's a heavy user, decades of regular use. And in that case, heavy use was associated with both low bone mineral density and an increased risk of bone fractures, about double the fracture rate, presumably due to lower bone density in the hip and spine. Though heavy cannabis users were also skinnier on average, and skinnier people have lighter bones. Hip fracture risk goes down as your weight goes up. Nearly half of underweight women have osteoporosis, but less than 1% of obese women do, which makes total sense. Being obese forces your body to make your bones stronger to carry around all that extra weight. That's why weight-bearing exercise is so important to constantly put stress on your skeleton. It's use it or lose it. That's why astronauts can lose 1% of their bone mass every month. Their bodies aren't stupid. Why waste all that energy making a strong skeleton if you're not going to put any weight on it? So maybe that's the only reason heavy cannabis users have frailer bones, because they tend to be about 15 pounds lighter? Wait a second, users are slimmer? What about the munchies? The lower BMI of heavy cannabis users may seem counterintuitive given the appetite stimulation, but this isn't the first time this has been noted. Pop culture depicts marijuana users as a sluggish, lethargic, unproductive subculture of compulsive snackers, and it's true that marijuana has been found to increase food intake. A single hit can increase appetite, and so you'd expect obesity rates to rise in states that legalized it, but if anything, the rise in obesity appeared to slow after medical marijuana laws were passed, where it appeared to just keep rising in other states. The reason pot smokers may be slimmer is because of the effect of smoked marijuana on metabolism. We've known for nearly 40 years that within 15 minutes of lighting up, your metabolic rate goes up by about 25% and stays there for at least an hour. So that may be playing a role. So is that why heavy cannabis use is associated with lower bone mineral density and increased risk of fractures? They're just not as overweight? No. Even taking BMI into account, heavy cannabis use appears to be an independent predictor of weaker bones.
Dating back to the original dietary goals for the United States in 1977, the so-called McGovern Report, leading nutrition scientists were not only calling for a reduction in meat and other sources of saturated fat and cholesterol like dairy and eggs, but also sugar. The goal was to reduce America's sugar intake down to no more than 10% of the daily diet. The final conclusions would hang sugar, reported the president of the Sugar Association. The McGovern Report has to be neutralized. Don't worry, though, we have the National Cattlemen's Association on our side, and like Big Sugar, they appealed to the Senate Select Committee to withdraw the report. The sugar industry empire, striking back, appeared to work. When the official dietary guidelines were released in 1980, and then again in '85, no specific limit, like 10%, just a vague avoid too much sugar, whatever that means. By 95, it got even vaguer. Choose a diet moderate in sugars. In 2000, they were released back to limit, but even that was too strong under pressure from sugar lobbyists. They went back to moderate your intake of sugars before the 2005 Guideline Committee dropped the S word completely, encouraging Americans to choose carbohydrates wisely, whatever that means. If only there were some kind of dietary guidelines committee that could give us guidance. The Sugar Association expressed optimism about that 2005 committee. The Sugar Association Incorporated is, quote, committed to the protection and promotion of table sugar consumption, and they will not allow for the disparagement of sugar. And they're not kidding. In 2003, the World Health Organization released a report, Diet, Nutrition, and the Prevention of Chronic Disease, which for the first time since the McGovern report called for a reduction in sugar intake to under 10%. The Sugar Association responded by threatening to get the U.S. to withdraw all funding from the WHO. Here it is in black and white. The Sugar Association threatening to pressure Congress to withdraw funding from the World Health Organization. Polio vaccinations, AIDS medications, be damned. Right? You just don't mess with the candy man. The threat was described as tantamount to blackmail and worse than any pressure they had experienced from big tobacco. But now, 15 years later, and 40 years after the first proposed McGovern report, the current 2015 to 2020 dietary guidelines lay out as a key recommendation the 10% limit, currently exceeded by every age bracket in the United States, starting at age 1, with adolescents averaging 87 grams of sugar a day, meaning the average teen is effectively eating 29 sugar packets a day. The Sugar Association describes the 10% limit as extremely low. Only like up to a dozen spoonfuls a day. But of course, there's no dietary requirement for added sugar at all, and every single calorie we get from added sugar is a wasted opportunity to get calories from sources that actually provide nutrition. To the American Heart Association's credit, they went further, trying to push added sugar intake down to about 6% of calories, for which a single can of soda could send you over the limit. An added sugar limit exceeded by 90% of Americans. In 2017, the American Heart Association released their guidelines for children, recommending they get no more than about 6 teaspoons per day, which means there's nearly 100 cereals on the U.S. market for which a single serving exceeded the entire recommended daily limit. And the Heart Association recommends no added sugars at all under age 2. Small toddlers are to avoid added sugars altogether, a recommendation that's violated in up to 80% of toddlers. The U.S. is one of at least 65 countries that have implemented dietary guidelines or policies to curb sugar consumption. In the UK, the Scientific Advisory Committee on Nutrition made new recommendations to reduce added sugars down to 5%, which is the direction the World Health Organization is headed as well. They always seem to be kind of ahead of the curve. Why? Because their policymaking process is at least partially protected from industry influence. Unlike governments, which may have competing interests in commerce and trade, the World Health Organization is exclusively concerned with health. In my video on flexitarians, I talk about how the benefits of eating a plant-based diet are not all or nothing. Right? Simple advice to increase the consumption of plant-derived foods with a parallel reduction in the consumption of foods from animal sources was found to confer a survival advantage, a live longer advantage. They call it a pro-vegetarian eating pattern, just moving in that direction as a more gradual, gentle, doable approach. If you're dealing with a serious disease, though, like diabetes, avoiding some problem foods completely may be easier than attempting to moderate their intake. It's like clinicians would never tell alcoholics to simply cut down on alcohol. Avoiding alcohol entirely is a more effective and ironically easier for a problem drinker. Paradoxically, asking patients to make a large change may be more effective than making a slow transition. Diet studies show that recommending more significant changes increases the changes that patients actually accomplish. It may help to replace the common advice, all things in moderation, with big changes beget big results. Success breeds success. After a few days or weeks of major dietary changes, patients are more likely to see improvements in weight and blood sugar levels, improvements that reinforce the dietary changes. Furthermore, they may enjoy other health benefits of plant-based eating that may give them further motivation. Those who choose to eat plant-based for their health say it's mostly for general wellness and disease prevention, or to improve their energy levels or immune function. They felt it gave them a sense of control over their health. Helps you feel better emotionally, improves your overall health, and makes you feel better. Most felt it was very important for maintaining their health and well-being. For the minority that used it for a specific health problem, it was mostly for high cholesterol or weight loss, followed by high blood pressure and diabetes, with most reporting they felt it helped a great deal. But others choose plant-based diets for other reasons, like animal welfare or global warming. It looks like they're more likely to be eating things like vegan donuts, right? Sugary and fatty foods, compared to those eating plant-based because of religious or health reasons. I mean, the veganist vegan could bake a cake using soda instead of eggs, with frosting covered in marshmallow fluff and chocolate syrup, topped with Oreos, with a side of Doritos, dipped in vegan bacon grease. But fruit for dessert, in the form of Pop-Tarts and Krispy Kreme pods. This is a vegan meal. Yes, plant-based diets have been recommended to reduce the risk of type 2 diabetes. However, not all plant foods are necessarily beneficial. Like in that pro-vegetarian scoring system, you got points for eating potato chips and french fries just because they were technically plant-based. But Harvard researchers wanted to examine the association of not only an overall plant-based diet, but both healthy and unhealthy versions. So they created the same kind of pro-vegetarian scoring systems weighted towards any sort of plant-based foods and against animal foods, and then also created a healthful plant-based diet index, where at least some whole plant foods took precedence, and Coca-Cola was no longer considered a plant. Then lastly, they created an unhealthful plant-based diet index by assigning positive scores to processed plant-based junk and negative scoring healthier foods and animal foods. And then they found that a more plant-based diet in general was good for reducing diabetes risk, but eating especially healthy plant-based foods did better, nearly cutting risk in half, while those eating more unhealthy plant foods did worse. But is that because they were also eating more animal foods? People often eat burgers with their fries, so they separated out the effects of healthy plant foods, less healthy plant foods, and animal food. And healthy plant foods were protectively associated, animal foods were detrimentally associated, and less healthy plant foods were more neutral when it came to diabetes risk. Here's what the graph looks like. Higher diabetes risk with more and more animal foods, no protection whatsoever with junky plant foods, and lower diabetes risk associated with more and more healthy whole plant foods in the diet. So they conclude that yes, plant-based diets are associated with substantially lower risk of developing type 2 diabetes risk, but it may not be enough to just lower the intake of animal foods, but also less healthy plant foods as well. The American Medical Association started warning people about excess sugar consumption over 75 years ago, based in part on our understanding that sugar supplies nothing in nutrition but calories, and the vitamins provided by other foods are sapped by sugar to liberate those calories. Hence, added sugars aren't just empty calories, but like negative nutrition. The more added sugars one consumes, the more nutritionally depleted one may become. Given the totality of scientific evidence, the FDA decided to make processed food manufacturers declare added sugars on the nutrition facts label. The National Yogurt Association was livid, opposing the added sugars declaration, since they needed added sugars to increase their product's palatability. The Junk Food Association questioned the science, whereas the ice cream folks seemed to imply consumers would be too stupid to use it, so better leave it off. The world's biggest cereal company, Kellogg, took a similar tack, opposing it so as not to confuse the consumer, and should the FDA proceed with such labeling against their objections, added sugar should at most be communicated in a footnote. See, their goal is to provide consumers with useful information so they can make informed choices. This from a company that describes their Froot Loops as packed with delicious fruity taste, fruity aroma, bright colors, made with whole grains, and lightly sweetened, a good source of fiber. Lightly sweetened, Froot Loops has more sugar than a Krispy Kreme donut. Froot Loops is more than 40% sugar by weight. The tobacco industry used similar terms like light, low, mild to make their products appear healthier before they were recently barred from doing so. Now sugar interests are fighting similar battles over whether their healthy, natural, lightly sweetened terminology is similarly deceptive. But just look at all those vitamins and minerals they added. That was one of the ways the cereal companies responded to calls for banning sugary cereals. General Mills defended the likes of Frankenberry, Trix, and Lucky Charms for being fortified with essential vitamins. Sir Grapefellow, I learned, was a grape-flavored cereal complete with sweet grape star-bit marshmallows. But don't worry, it was vitamin-charged. Sugary breakfast cereals, said Dr. Gene Mayer from Harvard, are not a complete food, even fortified with 8 or 10 vitamins. I think your point is well taken, replied Senator McGovern, that these products may be mislabeled, perhaps more correctly called candy vitamins than cereals. Plastering nutrient claims on the box can create a nutritional facade, acting to distract attention away from unsavory qualities such as excess sugar content. The majority of parents have been found to misinterpret the meaning of claims commonly used on children's cereals, raising significant public health concerns. Ironically, cereal boxes bearing low-calorie claims were found to have more calories on average than without such a claim. So it's like the cereal doth protest too much. Even candy bar companies are getting in on the action, bragging about their protein content, because it has some peanuts or something, but it's also a candy bar with 50 grams of sugar, just like Froot Loops could be considered breakfast candy, as the same serving would have 40. Given research suggesting consumers believe front-of-package claims, perceive them to be government-endorsed, and use them to ignore the nutrition facts panel on the back, there's been a call from nutrition professionals to consider an outright ban on all front-of-package claims. The industry's short-lived Smart Choices label was met with disbelief when it was found adorning qualifying cereals like Froot Loops and Cookie Crisp. The processed food industry spent more than $1 billion lobbying against the adoption of more informative labeling, a traffic light approach, railing against the suggestion that any food might be too high in anything. The #1 killer in the United States and on the planet Earth is a bad diet. That's why I've dedicated my life to the study of nutrition. Killer number 2 is high blood pressure. The reason it's so deadly is that it increases your risk of dying from so many different diseases, heart disease, stroke, to heart and kidney failure. We're talking an exponential increase in the risk of dying from a stroke as our pressures go up, starting from around 110/70, an exponential increase in the risk of dying from heart disease, again starting at a blood pressure around 110/70. We used to consider a blood pressure as high as 175 to be normal. Normal if you wanted to die from the normal diseases like heart attack and stroke. A quote-unquote normal of 175/110 could put you at over 1,000% higher risk of having you croak from a stroke compared to the ideal. Not the normal, but the ideal, which is down around 110/70. The definition of high blood pressure, hypertension, dropped from as high as 190/110 down to 160/95, with treatment thresholds for high-risk groups starting at 150/90 down to 140/90, and then most recently 130/80. Now, Instead of 1 in 3 Americans having hypertension, with the new definition, it's closer to 1 in 2, or more like 2/3 of those over the age of 45. Every time the threshold drops, labeling tens of millions more people diseased, there's this backlash. Same thing every time the cholesterol guidelines get more and more stringent, right? But don't blame the guidelines. Americans are diseased. That's the real problem. The American way of life is the problem, not the guidelines. Maybe we should focus on that instead. After all, the #1 killer of men and women is heart disease, a disease that can be prevented, arrested, and reversed with a healthy enough diet. So even though a cholesterol of 200 may be normal, maybe we should tell people to strive for under 150. Even though a BMI of 24.9 is technically not overweight, an average height woman, for example, would be better off down around 120 pounds than 145. And similarly, though a blood pressure of 120/80 may be normal, 110 would be a better top number, and 70 a better lower number. As even down in that range, between 70 to 75 or 75 to 80, each 5-point increment is associated with a third more stroke and at least a fifth more heart disease. So why are the new guidelines up at 130/80? With an average of 3 different blood pressure drugs, you can force people's blood pressures from 140 down to 120, compared to just giving them 2 blood pressure drugs. And high-risk people live longer because of it. Significantly less death in the intensive treatment group, but because of the higher doses and drugs, had more side effects. Right? So you have to weigh the risks versus benefits. 1 to 2% of people on the drugs for 5 years will benefit, not having a cardiovascular event when they otherwise might, and that has to be balanced against the higher risk of adverse side effects. So you'll hear commentators saying things like, yeah, the drugs decrease your risk of events by 25%, but increase your risk of serious side effects by 88%. OK, but those events can include things like death, whereas the side effects are more in the order of fainting. These adverse events do need to be weighed against the benefits with respect to cardiovascular events and death that are associated with intensive control of systolic blood pressure. Like if we use drugs to push high-risk people down to a top number of 120, we might prevent over 100,000 deaths and 46,000 cases of heart failure every year, but could cause 43,000 cases of electrolyte abnormalities, 88,000 cases of acute kidney injury. Right? I mean, not great, but better than dying. Right? So you can see the conundrum guidelines committees are in. Right? On one hand, lowering blood pressure is good for your heart, kidneys, and brain, but at a certain point, the side effects from the drugs could outweigh the benefits. Ideally, we want to get patients' blood pressures as low as possible, but only want to use drugs to do it when the effects of treatment are likely to be less destructive than the elevated blood pressure. The problem is that most people who die from heart disease, heart failure, and stroke may be in that borderline range, not sufficiently elevated to warrant drug treatment. Right? If only there was some way to lower blood pressure without drugs to get the best of both worlds. Thankfully, there are. Regular aerobic exercise, weight loss, smoking cessation, increased dietary fiber intake, decreased alcoholic beverage intake, consumption of a more plant-based diet, and cutting down on salt. The advantage is, first of all, no bad side effects. Right? Some lifestyle interventions can actually work better than the drugs because you're treating the cause and actually have instead good side effects. So not 1 or 2% benefit over 5 years, everybody benefits. We'll explore one drug-free approach, water-only fasting, next. Fasting has been practiced for thousands of years, but only recently have we started to put it to the test. I did a previous video series about the studies on using fasting for weight loss back in the 70s. Was it safe? Was it effective? But what about fasting for treating and preventing other diseases? One of the side effects noticed in the early weight loss studies was a consistent fall in blood pressure. So much so, you typically have to stop taking blood pressure medications while you're fasting, else your pressures fall too low. Once you start eating again, your pressures go back up, but remarkably not as high as they were before. But of course, it depends on what you start eating again. For example, a case report of a woman who used fasting to drive her rheumatoid arthritis into remission. Systolic blood pressure started up around 170, despite multiple blood pressure medications, was put on a whole food plant-based diet for 8 weeks. That dropped her down from 170 down to 130, off of all her medications before starting the fast, and then normalizing down to 110 after the fast. But is that just because of all the weight loss? I mean, she lost 22 pounds on the fast, and 27 pounds on the plant-based diet. So yeah, it's extraordinary to drop your pressures from 170 to 110, but that was after losing about 50 pounds. Right? We've known for decades that any kind of weight loss can lower blood pressure. Even minor weight loss can lower blood pressures in obese persons, even if they remain significantly overweight. But most of the drop in blood pressures with severe caloric restriction happens within the first 2 days, before significant loss of body fat. So it may also be a reduction in the fight-or-flight stress hormones, like adrenaline and noradrenaline, both before and after exercise, after just 2 weeks of just a few hundred calories a day. So that may be one reason why very low-calorie diets have been found useful in lowering blood pressures, even in those for whom blood pressure medications fail, the changes in those hormones. But low-calorie diets also tend to be more plant-based, so there's fiber and potassium-rich foods, less saturated fat. Even just adding fruits and vegetables to the diets of hypertensives can lower their systolic blood pressure, the top number, by 7 points. I mean, that's the kind of blood pressure improvement you might get losing 10 pounds, just by eating more fruits and vegetables. And if you combine that with a drop in meat consumption, not only doubling fruit and vegetable intake, but combining that with trying to slash saturated fat and cholesterol, right, you can cut pressures by 11 points. What else can we do? Restricting alcohol intake in regular daily drinkers can drop you 5 points. Right? So let's keep track here. Alcohol restriction can drop your systolic blood pressure 5 points. Losing 10 pounds can drop you 7, as can just eating the recommended 8 to 10 servings of fruits and vegetables a day. Regular aerobic exercise for at least 3 months can drop you 9. So let's add that onto the chart. Combine the fruits and vegetables with meat reduction, you can drop it 11. Blood pressure medications can have side effects, but on their own can drop pressures by 15 points. What about cutting down on salt? Note in the other diet study, they kept the sodium levels the same. Cut sodium enough, and it can edge out drugs at 16. The drugs, 15. Sodium restriction, 16. Is that the best we can do with diet? Put people on a purely plant-based diet, even one moderate in sodium, and you can drop hypertensives by 18 points, even after 9 out of 10 reduce their blood pressure medications or stop them entirely, all within just 7 days. That's pretty impressive. Now, what if you took that same diet, but added fasting? 37 points. Right? We'll review that study and others like it next. Medically supervised water-only fasting in the treatment of high blood pressure. 174 consecutive patients were treated in an inpatient setting. First, a few days of fruits and vegetables. This is to kind of clear out the gut so they don't become constipated, followed by 10 or 11 days of water-only fasting before transitioning them back to a whole food plant-based diet. Fruits, vegetables, whole grains, legumes, which are beans, split peas, chickpeas, and lentils, and nuts and seeds with no animal products, processed foods, or added salt, oil, or sugar. They all came in hypertensive, over 140/90, but 9 out of 10 of them, 89%, walked out with pressures under 140/90. The average reduction in systolic blood pressure was 37 points, which is remarkable compared to other interventions, including drugs. And that was just the average drop. Those came in with really high pressures, like over 180, experienced a 60-point drop. This is arguably the largest effect ever published in the scientific literature. And that was after they had all stopped all their blood pressure medications. They conclude that medically supervised water-only fasting appears to be a safe and effective means of normalizing blood pressure. I explored the safety in a previous video, and yes, extraordinarily effective, but for how long? I mean, fasting is the least sustainable diet out there, right? Interestingly, when they resumed feeding, their blood pressures dropped even further, suggesting fasting could be used to kickstart the normalization of blood pressure, and then you could keep it down from then on with a healthy enough diet. They were able to track down a few dozen patients much later, and on average, their pressures remained down. We don't know what happened to the rest, but it shows at least it can provide more lasting benefits for some. A subsequent smaller study followed up people up to a year later, and the blood pressure reduction seemed to hold along with the weight loss, so presumably they stuck with the healthier diet. Now, no one should be fasting for more than a day or two unsupervised, so this treatment certainly carries a cost, but the entire cost appears to have just been recouped within the first year, just from decreased medical care costs alone. An alternative is the Buchinger method of fasting, popular in Europe, where instead of water only, people get like 300 calories a day, and like fruit juice and vegetable broth. It still needs to be done under professional supervision, but at least people don't have to take time off work. People are randomized. 7 days of that, and then followed up 4 months later. After 4 months, you'd think any benefit from the 1-week quasi-fast would have disappeared, but their blood pressures ended up 15 points lower than the control group. Although long-term follow-up of these subjects has been sporadic, the available data suggests that these large reductions in blood pressure can be conserved in patients who remain compliant with the follow-up diet. In other words, a cure for hypertension may be feasible, though of course if they resume to the original diet that had made them hypertensive in the first place, that would presumably lead to a resurgence of their blood pressures. And the fast may actually help with that. The preliminary fast may help people stick to healthier diets that would ordinarily have little appeal to people accustomed to meretriciously salty and greasy meals. That is an SAT word if I ever saw one. I had to Google that one, but apparently attractive, but having, in reality, no value. Sounds about right. The secret to long-term benefits may be in helping kickstart the healthier diet by cleansing our palate, which has been so deadened by hyper-sweet, hyper-salty, hyper-fatty foods. After not eating for a week, your regular, normal, healthy, real food tastes good again. The ripest peach in the world would taste sour after a bowl of Fruit Loops. Right? But fasting may resensitize our taste buds, such that you can enjoy something like corn on the cob without the added butter and salt, so you can get the best of both worlds, taste great and less killing. Headaches are one of the top 5 reasons people end up in emergency rooms, and one of the leading reasons for which people see their doctors in general. One of the things you can try to do to prevent them is identify the triggers and avoid them. Common triggers for migraines include stress, smoke, hunger, sleep issues, certain trigger foods like chocolate, cheese, and alcohol, your menstrual cycle, or certain weather patterns. In terms of dietary treatments, the father of modern medicine, William Osler, suggested trying a strict vegetable diet. After all, the nerve inflammation associated with migraines may be reduced by a strictly plant-based diet, as many plant foods are high in anti-inflammatory compounds and antioxidants, and likewise, meat products may have pro-inflammatory properties, but it wasn't put to the test for another 117 years. Among those given a placebo supplement, half said they got better, half said they didn't, but when put on a strictly plant-based diet, they did much better, experiencing a significant drop in the severity of their pain. Now, it's possible that the pain-reducing effects of the plant-based diet may have at least been in part due to the weight reduction. They lost about 9 more pounds in their vegan month. Even just lowering the fat content of the diet may help. Those placed on a month of consuming less than 30 grams of fat a day, like less than 2 tablespoons of oil all day, experienced highly significantly decreases in headache frequency, intensity, duration, and the need to take medications. A 6-fold decrease in frequency and intensity, from 3 migraine attacks every 2 weeks down to just 1 a month. And by low fat, they didn't mean SnackWells. They meant more fruits, vegetables, beans. Right? Before the food industry co-opted and corrupted the term, eating low-fat meant like eating an apple, not Apple Jacks. Now, this is a really low-fat diet, like 10% fat for someone eating 2,500 calories a day. What about just less than 20% fat, compared to a more normal but still relatively lower-fat diet than average? Same significant drops in headache frequency and severity, including a 5-fold drop in attacks of severe pain. Since the intervention involved at least halving of saturated fat intake, mostly found in meat, dairy, and junk, the researchers concluded that a reduction of saturated fat intake may help control migraine attacks. But it's not necessarily something they're getting less of. There are compounds present in live green real veggies that might bind to a migraine-triggering peptide known as CGRP. Drug companies have been trying to come up with something that binds to it, but the drugs have failed to be effective and are also toxic, a problem you don't see with cabbage. Green vegetables also have magnesium found throughout the food supply, but mostly concentrated in green leafy vegetables, beans, nuts, seeds, and whole grains. It's actually the central atom to chlorophyll, so you can see how much magnesium foods have in the produce aisle by the intensity of their green color. Magnesium supplements do not appear to decrease migraine severity, but may reduce the number of attacks you get in the first place. You can ask your doctor about starting 600 milligrams of magnesium dicitrate every day, but note magnesium supplements can cause adverse effects such as diarrhea, so I recommend getting it in the way nature intended. Any foods that may particularly help? I've talked about ground ginger. Combining caffeine with over-the-counter painkillers like Tylenol, aspirin, and ibuprofen may boost their efficacy, about 130 milligrams for tension-type headaches and 100 milligrams for migraines, about what you might expect to get in 3 cups of tea, though I believe it's just a coincidence that the principal investigator was named Lipton. Note you can overdo it. If you take kids and teens who have headaches drinking 1.5 liters of cola a day, and cut the cola, you can cure 90% of them, though this may be a Coca-Cola effect rather than a caffeine effect. And finally, one plant food that may not be the best idea is this innocent-looking fellow, the Carolina Reaper, the hottest chili pepper in the world. So mind-numbingly hot, it can clamp off the arteries in your brain, and you can end up with a so-called thunderclap headache, like this 34-year-old man. Why am I not surprised it was a man? One phrase you'll hear repeatedly in my videos and books is best available balance of evidence. What does that mean? When making decisions is life or death important as to what to best feed ourselves and our families, it matters less what a single study says, but rather what the totality of peer-reviewed science has to say. Individual studies can lead to headlines like this. To know if there's really a link between secondhand smoke and lung cancer, it would be better to look at a review or meta-analysis that compiles multiple studies together. The problem is that some reviews say one thing, breathing other people's tobacco smoke is a cause of lung cancer, and some reviews say another, saying the effects of secondhand smoke are insignificant, and further, such talk may foster irrational fears. And hey, while we're at it, you can even directly smoke 4 or 5 cigarettes a day and not really worry about it, so light up. Why do review articles on the health effects reach such different conclusions? Well, as you can imagine, about 90% of reviews written by tobacco industry-affiliated researchers said it was not harmful, whereas you get the exact opposite number with independent reviews. Reviews written by tobacco researchers had 88 times the odds of concluding secondhand smoke was harmless. It was all part of their deliberate corporate strategy to discredit the science, to, in other words, develop and widely publicize evidence that secondhand smoke is harmless. OK, well, can't you just stick to the independent reviews? The problem is that industry-funded researchers have all sorts of sneaky ways to get out of declaring conflicts of interest, so it's hard to follow the money. Look, but even without knowing who funded what, the majority of reviews still concluded secondhand smoke was harmful. So just like a single study may not be as helpful as looking at a compilation of studies on a topic, a single review may not be as useful as a compilation of reviews. So looking at a review of reviews like this one can give you a better sense of where the best available balance of evidence may lie. In this case, it's probably best not to inhale. Wouldn't it be cool if there were reviews of reviews for different foods? Voila! An exhaustive review, meta-analysis, and systematic reviews on the associations between food and beverage groups and major diet-related chronic diseases. Let's start with the beverages. The findings were classified into 3 categories: protective, neutral, or deleterious. First up, tea versus coffee. In both cases, most reviews, for whichever condition they were studying, found both beverages to be protective. But you can see how this supports my recommendation for tea over coffee. Every cup of coffee is a lost opportunity to drink something even healthier, a cup of green tea. No surprise, soda sinks to the bottom, but still, 14% of reviews mentioned protective effects of drinking soda? Well, most were references to papers like this. A cross-sectional study that found that 8th grade girls who drank more soda were skinnier than girls who drank less. OK, but this was just a snapshot in time. What do you think is more likely? That the fatter girls were heavier because they drink less soda, or that they drank less sugary soda because they were heavier? Soda abstention may therefore be a consequence of obesity rather than the cause, yet it gets marked down as protective. It was a protective association. Study design flaws may also account for these wine numbers. This review of reviews was published back in 2014, before the revolution in our understanding of the evaporating health benefits of alcohol, suggesting that the presumed health benefits from moderate alcohol may have finally collapsed, thanks in part to a systematic error of misclassifying former drinkers as if they were lifelong abstainers, as I revealed in a deep dive in my latest video series on the subject. Sometimes there are unexplainable associations. So, for example, one of the soft drink studies found that increased soda consumption was associated with lower risk of a certain type of esophageal cancer. Now, don't tell me the review was funded by Coca-Cola. The review was funded by Coca-Cola. Does that help explain these positive milk studies? Were they all just funded by the Dairy Council? Even more conflicts of interest have been found among milk studies than soda studies, with industry-funded studies of all such beverages approximately 4 to 8 times more likely to be favorable to the financial interests of the study sponsor. Funding bias aside, though, there could be legitimate reasons for the protective effects associated with milk consumption. After all, those who drink more milk as a beverage may drink less soda, which is even worse, so they come out ahead. But it may be more than just relative benefits. The soda cancer link seems a little tenuous, not just because of the Coke connection, but it's hard to imagine a biologically plausible mechanism, whereas even something as universally condemned as tobacco isn't universally bad. As I've explored before, more than 50 studies have consistently found a protective association with Parkinson's, thanks to nicotine. Even secondhand smoke may be protective. Of course, you still want to avoid it. It may decrease the risk of Parkinson's, but increases the risk of an even deadlier brain disease, stroke, not to mention lung cancer and heart disease, which has killed off millions of Americans since the first Surgeon General's report was released. Thankfully, by eating certain vegetables, we may be able to get some of the benefits without the risk, and the same may be true of dairy. As I've described before, the consumption of milk is associated with increased risk of prostate cancer, leading to recommendations suggesting men may want to cut down or minimize their intake. But milk consumption is associated with decreased colorectal cancer risk. This appears to be a calcium effect. Thankfully, we may be able to get the best of both worlds by eating high-calcium plant foods, such as greens and beans. What does our review of reviews study conclude about such plant-based foods in comparison to animal-based foods? We'll find out next. Instead of just looking at individual studies or individual reviews of studies, what if you looked at a review of reviews? In my last video, I covered the beverages, with the majority of reviews that found some effects either way, finding at least some benefits to tea, coffee, wine, and milk, but not to sweetened beverages such as soda. As I explored in depth, this approach isn't perfect. It doesn't take into account things like conflicts of interest, such as industry funding of studies, but can offer an interesting kind of bird's-eye view on what's out there in the medical literature. What did the data show for food groups? You'll note the first thing the authors did was split it up into plant-based foods and animal foods. For the broadest takeaway, we can look at the totals. The vast majority of studies on whole plant foods show either protective or at the very least neutral effects, whereas most reviews of animal-based foods identified deleterious health effects, or at best neutral effects. Let's break these down, though. The plant foods consistently rate uniformly well, reflecting the total. But the animal foods vary considerably. As you can see, if it wasn't for dairy and fish, the animal foods total would swing almost entirely neutral and negative. I talked about the effects of the dairy industry funding in my last video, as well as substitution effects. Those who drink milk may be less likely to drink soda, a beverage even more universally condemned. So the protective effects may be relative, arising not necessarily from what they're consuming, but rather from what they're avoiding. This may best explain the fish findings. After all, the prototypical choice is between chicken and fish, not chicken and chickpeas. And not a single review found a single protective effect of poultry consumption. Even the soda industry could come up with a 14% protective effects, but despite all the funding from the National Chicken Council and the American Egg Board, chicken and eggs got big fat goose eggs. Also, like the calcium in dairy, there are healthful components of fish. The long-chain omega-3 fatty acids, not for heart health. In the most extensive systematic assessment of effects of omega-3 fats on cardiovascular health to date, increasing the fish oil fats had little or no effect on cardiovascular health. In fact, if anything, it was the plant-based omega-3s found in flax seeds and walnuts that was protective. But the long-chain omega-3s are important for brain health, thankfully. Just like there are best of both worlds non-dairy sources of calcium, there are pollutant-free sources of the long-chain omega-3s, EPA and DHA as well. The bottom line is that when it comes to diet-related diseases such as obesity, type 2 diabetes, mental health, bone health, cardiovascular disease, and cancers, even if you lump all the animal foods together and ignore any industry funding effects, and just take the existing body of evidence as face value, 9 out of 10 study compilations show that whole plant foods are, in the very least, not bad, whereas about 8 out of 10 of the reviews on animal products show them to be not good.